So it's just a question of where do we shade? How do I know it's going to be a solid line versus a dotted line? You know, that sort of thing. Right? So you look at all the different examples that I have here. The first one is just a graph of a linear function. Only on the line. The solutions are only on the line. And I could give you a quick example following along that. Like, for example, if x is equal to 1, follow the graph, that puts you at this location here. Here's 1. This location here has a y value of 5. All right. So if I take the 1 and plug it into the equation, I get a result of 5. All right. That's what an equation will tell us. All right. It'll give us an equality relationship, but more so in terms of the graph, anything that satisfies this equation must fall on that line. As opposed to the graph of the inequality, which is giving us a less than symbol. So what does that mean? You could come up with an infinite number of possible examples. So in this case, let's say I had an x value equal to 1. There's a lot of shaded area related to that. All right, what that's telling me is that if I were to plug a 1 into my inequality, four, right? I would be looking at y is less than 5. All right, so how does that equate? Well, it's really kind of interesting because we were working with number lines in the last unit, but those number lines were specifically in terms of x. What this is telling me is that I have a y number line. So if I take my number line and organize it vertically, this would be a set of y values. I'd have 0 in the middle, 1, 2, 3, 4, 5. Maybe a negative 5 here. You'd have infinity up here, if that's where you're going. You'd have negative infinity down here, if that's where you're going. In the last unit, again, it was organized horizontally, but it's the same general idea. What I would do is draw an open circle on 5 and identify every value going towards negative infinity. That would be everything less than 5. All right? But that's specifically only for the x value of 1. So what that's telling me is that x equals 1, I'd have an open circle at 5. So that's all of this. But then if I had, let's say, an x value of 0, if I plug in a 0 to my inequality for x, plug in a 0 here, what do I get? 4. So y is less than 4. So using the same idea, I'd be looking at open circle at 4 going down. If I did it for negative 1, I'd get a 3. Open circle at 3 going down. But all those decimal values would exist too. I could do it at 0.1, 0.2. I could do it at 4.37, all these different possibilities. So instead of doing it for every single possible x value, what we do is we get a sense of the boundary. So we would graph y equals x plus 4, and then we would shade below it because that's what the number line would be telling us. All right, all values that are less than anything along that boundary. All right, so that's the justification for why you shade. All right, because it would be really weird to draw little open circles along this boundary, because there would be infinitely many open circles. That would be terrible. I don't want to do that. So instead of doing that, just as a shorthand way of doing it, we just use a dotted line or a dashed line. All right, so it makes life a little bit easier. But that's the theory behind why this works the way it does. What most people do is they just kind of memorize the idea that if it's a greater than or less than symbol, it's going to be a dotted line. If it's greater than or equal, less than or equal, or just equal, it's going to be a solid line. And it's just a question of which way are you shading, all right? If it's greater than, you're shading above the line. Sometimes it's harder to see what's above and what's below, and we'll get into that in a second. If it's, I already lost my train of thought. If it's greater than, it's going to be above. If it's less than, it's going to be below. Greater than or equal works the same way. It's just a question of whether it's a solid or a dashed or dotted line. All right, so the examples below, we're talking about just practicing shading. So I want to shade the area that's above the line, the dotted line. So it's a little funkier when you're looking at lines that have, pretty extreme slopes. In this case, it's a slope of, I don't even know, but it's pretty big, like 5, 6, let's see. I'm looking for a solid value, -2, -2, and then it goes to like 0, 7. So not like 4.5, something like that. All right, so it's pretty steep. So it's a question of like what's above the line. All right, so the part that's to the left of it would actually be above. But you might say, well, it's going to be on either side of the line. So one thing you could do is test a value. Test an x value. And see where it plots. All right? What is the most convenient number in the history of mankind? 0. 1 is the second most convenient number in the history of mankind. So test x equals 0. Just the same way we did above, and see where that goes. If I plug a 0 into this inequality, what do I get? Y is greater than 7. All right? So what I would do is find 7 and then shade above, all right, in the upward direction. All right? So you just need a single value just to give you a sense of where you're going. All right? So since your choices are up or down, this is telling us to go up. All right? So then that tells me that everything that is going to satisfy this inequality would have to follow that same idea. It's going upward from that dashed or dotted line. So now that I have that piece of information, I just do a little shading. Poorly, of course. You don't get any extra credit for the quality of your shading. I mean, I went a little overboard here, so maybe I'll trim that back. All right, but I've seen people spend half of a class period during the day of a test making these perfectly shaded regions. And I'm like, oh, that's wonderful. You still got the same 3 points that the person who came up with this got, so I don't know why you're wasting your time. All right. So for the second one, and again, if you can clearly see what's above or below the line, then just go for it. But if you can't, then testing a value makes sense. The only time 0 can be a little iffy is if it actually falls specifically on the line, but that's pretty rare. So, or at least rare where it doesn't help you in some capacity. So plugging a 0 here, what do I get? I'll write x equals 0. Y is less than -9. All right, so at 0, I find -9, draw an open circle, and go down with that. So that's telling me to shade below. Little calculator trick for you. It won't tell you dotted or dashed. It does everything with solid lines. We don't need this. If you take your original inequality and put it in as an equality, so with an equal sign, so -2x minus 9, that little slashy thing on the left-hand side determines how the line is graphed. So if I go over, I hit the left arrow to that slashy thing and hit enter. First time, it'll create a bold line instead of a regular line. So if I did zoom 6 or just graph, it would come up with just a thicker line. So it looks nice. Not useful in this case. If I hit enter again, it gives me like an upper triangular shading. All right. There still is a little memory component in here. But on your TI, 83 or 84, you have this option here, which is the upper triangular one. Okay, I can't draw, so that's always my big issue. All right, that corresponds with a greater than symbol. The lower triangular corresponds with a less than symbol. All right, so we were looking at the second example. So it's a less than symbol, so I hit enter again to give me the lower triangular. I don't know, you may disagree, but I look at that and I have to suspend my disbelief a little bit, but I look at that and I kind of see a less than symbol. You might look at it and say you see a greater than symbol, but it looks like a little less than. I mean, but you can make the case the other way, but I've kind of convinced myself over the years that looks kind of like a less than symbol. It looks like, if you want to go even more basic, it kind of looks like an L, and less than, and that, L will start with. So you can go that route. But anyway, if I hit graph now,
oh my God.
It tells you where to shade. And you see how it's doing vertical lines? It's doing what I did with my test case. It's just doing it for a bunch of test cases. So it's giving you a sense of where your answer should be. The only thing is that it's not going to tell you if it's a dash or dotted. I go back and forth with what I call it. Or a solid line. All right. So you have to still know that, but that's not terribly complicated. I think in a case like, when you have an equation x equals or x greater than x less than, calculator is not going to help you there because all the equations have to be put in the form of y equals. So all bets are off here, but I think this one's a little bit more basic because it's saying x is more than 3. All right, so where's x more than 3? All over here. And all you'd have to do is ask yourself, okay, here, I'm at this location. Is x more than 3? It's negative 2. No, it's not. Here, yes, because 4 is more than 3.
Is it ever just like a straight line, like
horizontal?
Yeah.
Yeah, it would be if it said y greater than, less than, or equal to just a number.
Oh, okay.
All right, so to graph a linear inequality, solve the inequality for y, although there are other ways to do it. Graph the boundary line, solid scope for less than or equal or greater than or equal, dash for less than or greater than, and determine which side the shade and label the inequality of the shaded area. So subtract the 2x. You get y less than or equal to negative 2x plus 4. I then have to graph that. All right, we graph that the same way we graph a line. What's the first thing we look for when we're graphing a line?
Y-intercept.
Y-intercept. So I'm going to plot 4. Then I'm going to count off my slope down to right 1 consistently. I'll zoom in here because it's hard to do without that. I'm trying to do solid points here, but failing. Thicken it up, I guess. Okay, so then we just have to decide, am I shading here or here? So choice A or choice B? A. All right, so we're looking for values that are less than the line. All right, I did a solid line because it had a less than or equal to sign. So I'm going to shade all the values less than. Now it says label the inequality in the shaded area. So you can label that a bunch of different ways. I go the simpler route. We define our inequality in some way. Typically we call it a solution, so I'll call it S, and just chuck an S in there. That's just to satisfy New York State, basically, for the Regents exam. Right? Some sort of labeling needs to happen. But again, do it the same way. Negative 2x plus 4. I want to go in the less than direction, so enter until I get the one that looks like an L. Wrap. And there it is. At a minimum, use it to confirm your answer.
That's so satisfying.
All right. So your